Power amplifier linearization is becoming increasingly important for emerging wideband communications technologies such as LTE Advanced and 802.11 AC wireless LAN. In this video, we will introduce solutions based on Agilent's SystemVue electronic system level design software and wideband PXI test equipment. Agilent's SystemVue software is a tool for development and validation of communications and radar systems. It is a model-based design tool that leverages cutting-edge algorithms and Agilent's vast experience in RF test and measurement, providing a single platform for design, simulation, and testing. Modern communication systems, which use signals such as LTE Advanced or 802.11 AC wireless LAN, are faced with a conflicting requirement. On the one hand, their signals have a high peak-to-average power ratio, which has a tendency to drive the device into distortion and results in unwanted spectral emissions in adjacent channels. On the other hand, there is a requirement to operate with high power added efficiency. Both of these requirements should be met while still meeting signal distortion limits. SystemVue's digital predistortion library simplifies the process of modeling a device's distortion, including nonlinearities and memory effects, and generating predistorted waveforms for testing and validation. Performing digital predistortion measurements requires 2 to 5 times oversampling to accurately model the power amplifier's higher order nonlinearities. To support this, the M9392A vector signal analyzer with 250 MHz instantaneous bandwidth and the M9330A arbitrary waveform generator with up to 1 GHz modulation bandwidth can be used to support many emerging wireless communication standards. Now we'll demonstrate the use of SystemVue's digital predistortion library to model an amplifier's nonlinearities and apply digital predistortion. SystemVue's digital predistortion library includes a wizard which allows us to easily perform digital predistortion analysis on standards such as LTE and wideband CDMA, as well as a user-defined mode which allows analysis using any modulation format. The first step in the DPD analysis process is creating the oversampled waveform. The DPD wizard allows customization of the waveform parameters, or in the case of user-defined waveforms, you can select a waveform that you've previously created, such as this LTE Advanced waveform generated by SystemVue's LTE Advanced library. Clicking Download Waveform starts the waveform playback. In step 2, we make measurements of the input signal with a direct connection from our signal generator to signal analyzer, and then measure with the power amplifier in the path at around its 1 dB compression point. As with the signal generation, we need to measure with wide bandwidth to accurately model the higher order device nonlinearities. SystemVue interfaces with Agilent's 89600B vector signal analysis software to capture the data from any supported hardware, such as the M9392A VSA. In step 3, we can choose the analysis level for memory effects and nonlinearities, among other parameters. We click on the DPD Model Extraction button, and we can see the results. A net mean squared error of greater than 30 dB indicates a good quality model, and we can peruse the conversion plots of the device and the digital predistortion, and examine the theoretical results of our spectrum versus the ideal waveform and the actual PA distortion results from step 2. In step 4, we apply the digital predistortion based on our extracted model parameters to our original waveform and play this waveform on the signal generator. Next, we capture the output on the vector signal analyzer. This will be used in the 5th and final step. In our last step, we again play the waveform without predistortion and perform a final verification of the results. We can then compare the actual output of the power amplifier with and without predistortion applied. This has been a demonstration of Agilent's digital predistortion library for SystemVue and wideband PXI vector signal analyzer. For more information on Agilent's modular instrumentation and SystemVue software, please visit us on the web.